I would like to demonstrate the effect or the importance of having some way of feedback or sensor on a motor, and how that can make the motor hold up to its environment. So this is a 150 watt motor from an electric scooter, so it could be used for a lot of things. I hope to use it as a cutting tool on a CNC router, and I want it to maintain a constant speed no matter if it's cutting wood or aluminum, whatever. So first what we'll do is make the motor spin at approximately 1500 RPM with a duty cycle. So this is a transistor, it's a MOSFET, and the Arduino will pulse the motor on and off using a MOSFET at about 44%, or not 44%, but 44 out of 255, so maybe about 20% duty cycle, and we'll see how close that gets us to 1500 RPM, and then we'll also feel the motor to see what happens when we put load on it. So first I'll just power this up, and our measured RPM is about 1500. That's what we want. Now I'm gonna put some load on it. Just put my thumb on this, and without really having to fight too hard, I've got the RPM down to 750, even 500, and it takes a while for the motor to come back to speed. So this is the kind of behavior I don't want, and that I'm facing right now whenever I cut harder materials. I end up having to set my router spindle to a higher speed than I need it, so that when it starts cutting, it slows down to the proper speed, which isn't really good. So now what I will do is put this in feedback mode, which means it's going to use the measured RPM to adjust the duty cycle, and actually will increase the power sent to the motor and try to maintain that 1500 no matter what we do to it. So let's see what happens. So we're hitting about the same speed, 1550, and now I'm going to start pushing on it, and it drops down to 1500, but I can't get it any lower, maybe 1490, and it's actually starting to burn it hurts, pressing on it that much. You can hear a little bit of change, but when you look at the numbers, it's actually only a difference of about 50 RPM, so maybe less than 10%. So I'm going to turn the motor off. So what that proves, first of all, I'm really happy that the motor is able to keep the RPM just about constant no matter what I do to it. This may actually work in as a spindle. So then, if you're wondering about this encoder that I have set up, it's just a 3D printed wheel with a slit in it, and then an infrared interrupter, probably pulled from an old inkjet printer. They're pretty cheap and simple. It only has 1 tick per revolution, which means I'm going to be limited at how fast the system can respond. If I had 100 slits per revolution, then it would get updates on the speed of the motor much more quickly. But I'm pretty happy with how that worked, and I think it's going to not be a problem. Anyway, I hope that you thought that this was pretty cool, and if you do get a chance to play around with something like this yourself, it is amazing to feel the difference between sensorless and with the sensor. So thank you for watching, and we'll see you next time.